Permutation and Combination. Permutation is a mathematical technique that determines the number of possible arrangements in a set when the order of the arrangement matters. With permutation, every little detail matters. Alice, Bob, and Charlie is different from Charlie, Bob, and Alice, and the order matters. And there are two types of permutation. Repetition is allowed and no repetition. Permutation with repetition. These are the easiest to calculate. When a thing has n different types, we have n choices each time. For example, choosing 3 of those things, the permutations are n times n times n, where n is multiplied 3 times. In other words, there are n possibilities for the first choice, then there are n possibilities for the second choice, and so on, multiplying each time, which is easier to write down using an exponent of r, which is n to the power of r. Example: in the log above, there are 10 numbers to choose from, which is 0 up to 9, and we choose 3 of them, so we have 10 times 10 times 10 up to 3 times, so we have 10 to the power of 3, which is equal to 1000 permutations. And simply, the formula is n to the power of r. Permutation without repetition. In this case, we have to reduce the number of available choices in each time. Without repetition, our choices get reduced each time, and it is associated with factorial function, which means to multiply a series of descending natural numbers. Example: 4 factorial is equal to 4 times 3 times 2 times 1, which is 24. 3 factorial is equal to 3 times 2 times 1 equals to 6. 2 factorial is equal to 2 times 1 equals 2, and 1 factorial is equal to 1. Example: how many ways can first and second place be awarded to 10 people? And we have the formula, which is n factorial over the quantity of n minus r factorial. In the example, we have 10 people, so we let n to be 10 and r to be 2 since we are only choosing first and second place. And to substitute, we have 10 factorial over the quantity of 10 minus 2 factorial, which is 10 factorial over 8 factorial, which is equal to 90. Combination. A combination is a mathematical technique that determines the number of possible arrangements in a collection of items where the order of the selection does not matter. In combination, you can select the items in any order. Combinations, on the other hand, are pretty easygoing. The details don't matter. Alice, Bob, and Charlie is the same as Charlie, Bob, and Alice. Or in short, the order doesn't matter. And there are two types of combination: combination with repetition and combination without repetition. Combination with repetition. A combination with repetition of r objects from n is a way of selecting r objects from a list of n. The selection rules are: first, the order of selection does not matter, or the same objects selected in different orders are regarded as the same combination. Next, each object can be selected more than once. Example: let us say there are 5 flavors of ice cream, which is banana, chocolate, lemon, strawberry, and vanilla. We can have 3 scoops. How many variations will there be? Let's use letters for the flavors: B for banana, C for chocolate, L for lemon, S for strawberry, and V for vanilla. Example selections include 3 scoops of chocolate, 1 each of banana, lemon, and vanilla, and 1 of banana and 2 of vanilla. To have a better understanding, think about the ice cream being in boxes. We could say move past the first box, then take 3 scoops, then move along 3 more boxes to the end, and we will have 3 scoops of chocolate. We can write this down as the symbol of arrow and circles. Arrow, which is to move, and circle, which is to scoop. As what you have noticed on the example, there are 5 flavors to choose from, yet we only move 4 times to complete 3 scoops. And to generalize, there are r plus n minus 1 positions, and we want to choose r of them to have circles. And we have this formula, which is the quantity of r plus n minus 1 factorial over r factorial over the quantity of n minus 1 factorial, where n is the number of things to choose from and we choose r of them. Repetition is allowed and the order doesn't matter. To solve, we substitute the values of r and n to the formula, which is the quantity of 3 plus 5 minus 1 factorial over 3 factorial times the quantity of 5 minus 1 factorial, which is equal to 7 factorial over 3 factorial times 4 factorial, which is equal to 35. So therefore, there are 35 variations. Combination without repetition. A combination without repetition of R objects from N is a way of selecting R objects from a list of N. The selection rules are: the order of selection does not matter. The same objects selected in different orders are regarded as the same combination, and each object can be selected only once. So we adjust our permutation formula to reduce it by how many ways the objects could be in order, because we aren't interested in their order anymore. So we have the formula n factorial over r factorial times the quantity of n minus r factorial. And for the example, in a bucket, there are 10 balls. Every ball is numbered from 1 to 10. If somebody pulls out 3 of these balls randomly, how many combinations of could he take? So here, we have 10 balls, which is the number of things to choose from. So we take 10 to be n and r to be 3. So substitute the given information to the formula. We have 10 factorial over 3 factorial times the quantity of 10 minus 3 factorial, which is equal to 120. And to have a better understanding between permutation and combination, let us see the difference between permutation and combination. In permutation, it is all about arranging people, digits, numbers, alphabets, letters, and colors, picking a team captain, pitcher, and shortstop from a group, picking two favorite colors in order from a color brochure, picking first, second, and third place winners. While in combination, it is about selection of menu, food, clothes, subjects, team, picking three team members from a group, picking two colors from a color brochure, and picking three winners. That would be all. Thank you for watching.